Problem 6 asks us to calculate the effective nuclear charge, or Z effective, experienced by the valence electrons in carbon and silicon. Both of these are in group 4A. We're told to use the equation Z effective equals Z minus S, and the electron shielding constant S that is estimated as the number of electrons that are in principal energy levels lower than that of the valence electrons. And we'll see what that means in a minute. To calculate the effective nuclear charge using the Z effective equation, we must first determine Z and S. Z is simply the nuclear charge, which is the number of protons and the atomic number. In case of carbon, it's 6, and in silicon, it's 14. S is the approximate shielding constant that is estimated as the number of electrons that are in principal energy levels lower than that of valence electrons. Therefore, we need to look at the ground state electron configurations for both atoms. Carbon, as we can see here, has 4 valence electrons in the 2s and 2p principal energy level. This is n equals 2. And we could also see that the electrons that are in the lower energy levels are the 2 core electrons in this 1s orbital. So the value of S in this case equals 2, and Z equals 6. So we can see here 6 minus 2 gives us the Z effective value for carbon of positive 4. Now let's look at silicon. Silicon has 4 valence electrons in the 3s and 3p orbitals. Here n equals 3, which means lower energy levels contain 10 electrons. So in this case, S equals 10, and Z, which we get from the periodic table, is 14. And we can see here 14 minus 10 also gives us a positive 4 Z effective charge for silicon. So although they have about the same effective nuclear charge, silicon atoms are bigger than carbon atoms, well, because silicon's valence electrons are in the larger 3s and 3p orbitals, making them further away from the nucleus and therefore a larger radius.